Everybody, we returned again to the heat exchanger, and today we have one of the most important type, which is shell and tube heat exchanger, the most famous one. Okay, shell and tube heat exchanger. We will discuss the overview, main component, applications, advantage and disadvantage. What is shell and tube heat exchanger? A heat exchanger where one fluid flow inside tube and the other flow around the tube within the shell, inside the shell. Used widely in process industry, and the main component of the shell and tube heat exchanger: shell, tube sheet, baffle, channel and nozzle and gasket. Here is the uh, general diagram describing the heat and heat exchanger shell and tube normally, and this type first of all is U-tube. Okay, U-tube heat exchanger. This is normally we can find here the tube inlet and the tube outlet, as we can see here. Okay, and this is the shell. We can find here easily the shell nozzle outlet and the shell inlet. So this is the general component of the shell and the tube heat exchanger, and you can find easily the main component involved in this type of exchanger. So if we describe the heat exchanger shell and the tube, you will find here this supported concrete and saddle supported metal for expansion. Okay, shell inlet, shell outlet, tube inlet, tube outlet, and a channel cover, and head nozzle inlet also, pause partition, as we can find here. But the most important question here, when you have to use the U-tube shell and the tube heat exchanger, okay, this is the most important question. Best choice when delta T is high. Remember this: when the temperature is high, more than 50 degrees C, more than 60 degrees C, you have to choose this type of shell and tube heat exchanger. Okay, so when there is a large temperature difference, you have to choose U-tube heat exchanger. When fluid operate at high temperature, ideal for heaters, reboiler, and hot oil service, something like that. Thermal expansion is absorbed by the U-bend. Here the U-bend absorbs the thermal expansion. When you want to avoid expansion joints, you have to select U-tube. When tube side fluid is clean or moderately clean, when lower cost than floating head is needed. So the advantage of selecting this type of exchanger is handle large thermal expansion, lower cost than floating head, high pressure capability, reduce leakage risk. Okay, suitable for severe services. Okay. So this is the second type we will discuss, which is a fixed sheet heat exchanger in comparison to the floating head. So we have a fixed tube sheet and floating head. Floating head can be clearly in this shape. You can find a floating head. Look here, in the floating head, the same component as we discussed before. Okay, you have shell and the tube. Here the inlet of the tube, here the outlet of the tube side. Okay, here is the inlet of the shell and the outlet of the shell, whatever. Okay, but here you remark a floating head, and you remark that the length of the tube here is more than what we mentioned in the fixed tube sheet. The fixed tube sheet end at this point. Okay, end at this point, but here it little bit expanded here and covered by the floating head. You have to remark simply and focusedly what is the difference between the fixed tube sheet and the floating head. The floating head, you will remark in the floating head type, the length of the tube is little bit higher, but in the fixed tube sheet you will find this part repeated, one at the left side and the other at the right side. Okay, so this clearly the fixed tube sheet. You find this ended to fix the tube sheet on the right side, and this fixed to collect the tube at the left hand side and right hand side. Okay, with inlet and outlet. If we need to make a comparison between a fixed tube sheet and floating head heat exchanger, when you will select each one, and when to choose a fluid in the tube and to choose fluid in the shell. The first question, general rule: put the more critical, high pressure, dirty or corrosive fluid inside the tube. Okay, remark this, focus on this. Put the more critical, high pressure, dirty or corrosive fluid inside the tube side. Put the cleaner, low pressure, high flow fluid on the shell. I want to make this comparison clearly, when to select the tube side, when to select the fluid in the shell side, as the following. The criteria: if you are working with high pressure, put this in the tube side. Don't put it in the shell side. If you work with corrosive material, very corrosive material, put this corrosive material in the tube side. Material or fluid dirty and can cause fouling, put it inside the tube side. Okay, if there is a phase change, what we mean by phase change? Evaporation, something like that. The liquid water evaporate and there is some vapor. Okay, so don't put it in the tube, put it easily in the shell side. High flow rate, we can easily put it in the shell side. Easy and the maintenance, you put this fluid inside the tube. So keep this table as a guide for you when you make the selection, the decision and the selection of choosing which fluid will be directed to tube or directed to shell. Okay, so at this point we mentioned the main composition of the heat exchanger, shell and the tube. Okay, here this is the main component for shell and the tube heat exchanger, and we described the U-tube type and what is the advantage of this U-tube type. Okay, and we mentioned fixed tube sheet and the floating head. And finally, I want to make a description or comparison between both of them, simply to guide you when to select a floating head or choosing fixed tube sheet. The feature here is tube sheet design. Okay, tube sheet design. The tube sheet are rigid, fixed to the sheet, as we see in the drawing. Okay, so in comparison to the floating head, one tube sheet is free to move, which is in the right, as we see in the diagram, like this. Okay, one fixed and one here can be expanded a little bit, if you remark. So in the floating head, one tube sheet is free to move. For the thermal expansion, you can get the conclusion. Okay, limited here, shell and the tube expanded together. Here is limited. He allow the expansion because we have the floating head free in the right side. Okay, temperature difference. This is suitable for small temperature difference. The fixed tube sheet for small temperature difference, but the floating head is excellent for large temperature difference. For the maintenance, here the floating head is easy to clean, both tube and shell. Here little bit difficult. Tube bundle remove not removable, but in the floating head the fully removable, and this make it easy to clean. Okay, for sure we are better in the side of floating head. It's expensive, little bit expensive when you comparison the capital cost of this exchanger in comparison to the fixed tube sheet. Here the floating head will be little bit higher. Okay, complexity, more complex design for the floating head. Okay, and leak risk, this is very important, slightly high. More sealing point, here low, few, because there is few joints. Okay, typical application here, clean service, moderate temperature. If you are working with a dirty service, a high temperature, you have to choose the floating head. So we made in this lecture small and simple lecture comparison between the fixed tube sheet and the floating head. Let me return back to the diagram again. As we mentioned, this is a floating head. Where is the floating? Here is the cover for the floating head cover. Okay, here little bit expanded, more than the shell contained. Okay, and here the fixed tube sheet. Generally, you will remark that the floating head is recommended, but there is some certain cases, you can select the text-to sheet. One of them is the capital cost selection. And finally, I want to thank you for listening and appreciate it. Thank you.